This is my presentation about data structures and algorithms. I'll be talking about what data structures are, what their types are, how we can use them, how we can measure their efficiency. Especially I'll be talking about Big O. So basically Big O is just a way to measure the efficiency of algorithms and compare them. So I'll start with data structures. So basically, data structure is a way of organizing and storing data. There are different ways to organize and store data, and I'll specifically be talking about arrays, linked lists, stacks, queues, trees, graphs, and hash tables. So depending on data structure, we can make our program work faster or slower. I'll start with arrays. So it's a very simple way to store data. So for example, on the right we can see numbers 10, 20, 30, 40, and we can access each number by their index, and we are storing the data starting from 0. So what I mean, it starts with 0, 1, 2, 3. So for example, to get the access, to get the 10, we need to write its index, and its index is 0. So, and the index of this 20 is 1. So here I've got an example, and we can see how we can get the access of this data. We can also loop all those numbers, and basically what this code does, it just prints every number. So as a result, we'll see just 10, 20, 30, and 40. So it's very simple to store data. It's very fast and efficient. So the next way to store data is linked lists. So a linked list just stores data in nodes, and each node has the access to the next node. So for example, here we've got some values like 1, 2, and 3, and A has like the access to B, and B has the access to C, and one node links to another node. It's very easy to remove and insert items, and just also a very good way to store our data. But we don't have the access by index as arrays, and it stores more memory and it's slower to search. Next way of storing data is stacks. So basically here on the right we can see the example. So we've got we create a stack, and then we push our items. So we basically just add the items. So we add a book, a pen, and a phone, and they are added at the same order. So we've got book, pen, phone, and then we start removing those items. So we start removing with the last item we added. So if we remove phone first, then we remove our pen, and then all we've got left is just a book. And then if we want to add them again, we can use this append method. So basically it works like last in and last out, first out, So it's very easy to implement, and it's just also very fast. Alright, so the next one we've got queues. Queues are very similar to stacks we had before, but there is a small difference. So we also add John, Tom, and Dom, for example, here. But then when we start removing those items, we are removing from the first item. So we've got John, Tom, and Dom, and when we remove an item, we remove John first. So he was added first and he's removed first. And then we're removing Tom. And what we've got Dom, so the last item is left. Also, it works very fast and quite simple. The next way of storing data is trees. So we've got a root node, and each node can have child nodes. So in our example, we've got a root node which is 10, and we've got two childs, which is 5 and 15. And the example of this way of storing data can be file systems. So for example, we've got one folder, and inside that folder we can have a lot of different folders. Another example can be HTML page structure. So we can have like a big container, div container, for example, and it can have some paragraphs, pictures that are stored inside it. Right. It's very easy to add elements and remove some elements